Okay guys, so here's a little video on our introduction to inverse trig functions. And notice these are now inverse trig functions, different from our reciprocal trig functions. So the worksheet that you guys are doing today, you can read through the first part. It actually shows you how to tell the calculator to draw an inverse graph. Notice I say inverse graph and not an inverse function because it depends on your input. So if you want to play around with that, you can, but we have graphed inverses before. So I'm just going to jump right to graphing these. So to start off, we are graphing the inverse sine, but I'm actually going to graph our normal sine graph here. So I'm going to throw that onto my diagram, nice and small points. I'll put a couple extra here. And then remember, to graph the inverse, we can switch our x and y values. So 0, 0 is going to stay the same. And then check out what happens to our x and y axis. Now I need my pi units to be on the y-axis and my units of 1 and -1 to be on the x-axis. So instead of pi over 2, 1, I'm going to have 1 pi over 2, and then I'll have 0 pi. So now I'm just getting this sideways sine curve that's going up into space. And of course, you could always turn your paper or turn your head to make this look like our regular sine graph. So for our original sine function, we know our domain and range. And if we remember our inverse functions, those should swap. So now my domain is -1 to 1 inclusive, and my range is all real numbers. But the way we have it right now, this graph is not a function, right? It definitely does not pass our vertical line test. So they needed to change that, right? If you guys have heard about these before, so the inverse sine or arc sine is just another way to write it. They are functions. So I suggest that you actually go to Desmos or your graphing calculator and use the inverse sine button. There's a little inverse sine button above the sine if you press second, and that'll graph the inverse sine function for you. So make sure you have a nice window, and I would pause the video and go ahead and do that. Okay, once you're set, you will notice that the inverse sine just took our graph up here between -1 and 1. So the closest values from -1 to 1 are what they took. So I'm going to graph these 3 points and put that curve in there, just like if I was going to continue drawing our sine wave up the y-axis there. So my 3 key points now that we can use are -1, negative pi over 2, 0, 0, and 1 pi over 2. So when we graph the inverse sine function with all of its transformations, we'll just use these 3 points. It's a finite graph. It only goes from -1 to 1, and the range only goes from negative pi over 2 to pi over 2. Oh, inclusive there too. It's helpful to think about this range on our unit circle also. I really like to think about that because we'll see in the end of this section, it's helpful to kind of get a visual of where we are allowed to get answers from the inverse sine function. All right, so that's our inverse sine. I'm going to create one more video for our inverse cosine and inverse tangent, but you guys can go ahead and try those out on your own if you're feeling good.